Welcome to Power Electronics Education Electronic Book, Tutorial 3 Diode Rectifiers. This tutorial is presented by Dr. FIRUZ ZARE. So in this case we have to find the capacitance value in a single phase diode rectifier. So when we have a single phase diode rectifier, means we have AC to DC converter, that means if the line voltage is AC at 50 Hz, the output voltage across this terminal is rectify. We have full wave rectifier. So when this output is connected to only a resistive load, this is the voltage waveform, but because the output voltage fluctuates significantly, so this type of voltage waveform is not suitable for different applications. So that's why we basically put the capacitor in parallel with the load. So in this case, the output voltage will be something like this voltage waveform. So when the input voltage is root of 2 times of 240 times of sinus 2 pi t over t. That means this peak value is root of 2 times of 240. If the voltage across the capacitor is fully charged at this point and then discharged at this point, that means the ripple across the capacitor, which is defined as 2 delta V, can be calculated based on the capacitance value and other parameters. Let's look at the voltage waveform. So let's redraw the voltage waveform. So if this is the voltage waveform, suppose that charging time is much less than discharging time. That means suppose this time is negligible compared to this time, because this is basically half a cycle. So in this case, if this is a voltage across the capacitor, that means this is a voltage across the resistor or across the load. So suppose that the average of this voltage is V max minus delta V, because if this voltage is V max, which is root of 2 times of 240, and if this ripple is peak to peak is 2 delta V, so this average is V max minus delta V. So now let's look at the load current. So output voltage divided by resistor is output current, and in this case we concentrate on current through the resistor. Suppose that the ripple is negligible, so in this case the output voltage is Vm minus delta V over R. Now we can write the equation for capacitor. C dVc over dt is current through the capacitor. So if you look at the circuit diagram, for the time that capacitor is discharged through this resistor, the current through the capacitor is basically load current. So now we can simplify the equation. That means C times of, so delta V means that the voltage is decreasing, so delta V from this peak down to this point is minus 2 delta V over delta T basically is this half a cycle, that means T over 2 equals to current through the capacitor when the capacitor is discharged is basically minus IR, or C times of 4 delta V over T with this sign is minus equals to, and because here we have load current is minus Vm minus delta V over R. Now we can simplify this equation. So if I rewrite it again, then we have 4 CF delta V, which is equal to Vm minus delta V over R, or 4 CF R delta V equals to Vm minus delta V. So finally delta V 1 plus 4 RCF equals to Vm, and delta V is Vm over 1 plus 4 RCF. So for this example we can find capacitance value in terms of these parameters. For example, in this case we can find R, which is basically output voltage divided by current, and if we have power we can find based on this equation output squared divided by power. So here we can find the resistance value, and then in this equation suppose that the grid frequency is 50 Hertz. So if delta V should be kept at 20 volts, then in this equation we know Vm because Vm is root of 2 times of 240. So that means in this equation we know Vm, we know delta V, we know frequency, and we know the resistance value. Then we can find the capacitance value for this application. So in this example we have a diode rectifier which is connected to a pure inductive load. We consider pure inductive load as a current source. So the point is that the input current is not sine wave. So the input current is a square wave, and this square wave basically consists of sine wave plus harmonics. So the point is that we have to find these harmonics. So in order to find the input current and its harmonics, we can use Fourier analysis. That means if input current can be defined in terms of different sine and cosine terms, that means in this case I in equals to constant value, which is DC part, plus sum of sine and cosine terms, which is basically an cosine 2 pi t over t times of n plus bn sinus 2 pi t over t times of n. So the case is that we have to find these factors to be able to define this current in terms of cosine and sine functions. So an, which is basically a DC part for a periodic signal, is 2 over t times of this integral over 1 cycle times of I in t dt. And an is 2 over t, this integral over 1 cycle, which is I in t cosinus 2 pi t over t times of n dt, and bn is 2 over t over this integral, which is I in sinus 2 pi t over t times of n dt. So in order to find these factors, we need to look at the input current. Basically, input current is change from positive I out down to negative I out. And because each interval is t over 2, that means the DC part is 0. So for this case, this DC part is 0. That means A0 is 0. And now we can find these factors. So basically we can rewrite again, and sometimes because of symmetry we can simplify the equation. So let's concentrate on an. So an is 2 over t. So we can split the interval into 0 up to t over 2. In this case, load current is amperes. That means input current equals to I out times of cosine 2 pi t over t times of n dt plus 2 over t times of t over 2 up to this one, which is upper limit, times of, in this case, load current amperes in different direction. That means input current is minus I out times of cosine 2 pi t over tn dt. So now we can simplify again. That means 2I out over t times of integral of cosine is sine, so t over 2 pi n times of sinus 2 pi t over t times of n, and the limits of integral is between 0 and t over 2, plus same for the second terms, except we have negative here. That means we have minus 2i out over t times of t over 2 pi n, and integral of cosine is sine, which is sinus 2 pi t over t times of n, and this limits of integral is t over 2 up to t. So these two terms are 0 because sinus 2 pi t over 2 divided by t times of n equals to sinus pi n, and for any n we have 0, and lower limit means sinus 0, which is always 0 in this equation. Sinus 2 pi t over t times of n equals to sinus 2 pi n, which is 0. So in this case we can see that an is 0 while we have to find bn. So for bn we have 2 over t times of, split the integral into two different intervals, t over 2. Now for the first half a cycle, input current is I out times of sinus 2 pi t over t times of n dt, plus the second half a cycle. That means the limits of integral is between t over 2 and t, and in the second half a cycle input current is minus I out times of sinus 2 pi t over t times of n dt. So in this case we have 2 I out over t times of, integral of sinus is minus cosinus, and we have to consider this factor. That means minus t over 2 pi n, and the integral is cosinus 2 pi t over t times of n, in which the limits of integral is between 0 and t over 2, plus the second term 2 times of minus I out over t times of this integral, which is minus t over 2 pi n times of cosinus 2 pi t over t times of n, and the limits of integral is t over 2 and the upper limit is t. So now we can simplify this equation. So in this case we have minus 2 I out, so this one and this one can be cancelled over 2 pi n. So put the upper limit, that means cosinus 2 pi t over 2t times of n minus cosinus 0, and the second term, minus times of minus is plus, this t and this t we can cancel, it's 2i out over 2 pi n, and the limits of integral cosinus 2 pi t over t times of n minus cosinus 2 pi t over 2t times of n. So in this case we can simplify again. So now we can simplify this equation. That means in this case we have minus I out over pi n, and in this term cosine n pi minus cosine 0 is 1 plus I out over pi n cosinus 2 pi n minus cosinus pi n. So now we have to simplify based on odd and even number. Suppose n is an even number. So in this case, this term is always 1. That means 1 minus 1, this term is 0. So this term is always 1, and this one is 1 as well. So they can cancel each other. So that means this term is 0. But if n is an odd number, then cosine n pi is minus 1. That means this term will be minus 2. So minus 2 times of this factor is plus 2i out over pi n plus, and in this case this term is always 1, but this term is minus 1. Minus times of minus is plus, so again this whole term is plus 2. So 2 times of this term is 2i out over pi n. So we have 4i out over pi n. For example, in this case B1 is 4i out over pi, or B3 is 4i out over pi 3.